All right, thanks for tuning in. Brandon Clayton, the Algebra Guy here today. We will be discussing how to simplify using zeros, identities, and inverses. These are very basic when it comes to solving and simplifying any types of problems, and it'll make your life a lot easier. So tune in as we set this up as well as practice on how to do just that. Some of these are going to come very naturally to you because they make sense. So the questions I want to answer today, or the topics that I want to cover, is recognize the identity properties of addition and multiplication, use the inverse properties of addition and multiplication, use the properties of zero, and simplify expressions using the properties of identities, inverses, and zero. So let's get to it. I'm going to take out the pen. Bam. Yes, we're ready to go. All right, so first let's start with the identity properties of addition and multiplication. Identity. What is identity? Well, identity simply means who you are, right? So if you were to look in your mirror, you see yourself. This is your identity. So in that sense, we're going to talk about the identity properties of addition and multiplication. And to think about that, let's just think about a number. Okay, we're going to call that number A, any number, 1, 2, 3, 4, 5. We're going to let it be represented by the number A. So if we had the identity of the identity property of addition, we want to know what can we add to A to get the same thing, because that's the identity. So it makes sense, right, to add 0 to it and you get the same thing. So whether you put A plus 0 or 0 plus A, you're going to get A. So that's how you represent the identity property of addition. What about the identity property of multiplication? What if I had 3? How do I get a 3 back after multiplying it by something? So you see here that you take that number and you multiply by 1. Well, 1 times anything is going to give you that same thing, that same number. So that's called the identity property of multiplication. All right, so and if you were to see that in action, if you will, it looks like this. So this first one would be the identity property of addition, and this second one, obviously, the identity property of multiplication, because you're multiplying negative 16 times 1 to get negative 16. What about the identity property of 0? So to get a 0 as our answer for addition, we're going to take that number, in this case A, and add a negative value to it, right? So if we had an A plus negative A to give us 0. Negative A is the additive inverse, is what we call it, of A. But also know that if we originally had a negative A to start off with, we would add A to get the 0. So that would be the additive inverse in this case. What about multiplication? For multiplication, this is a very important step and will save you a lot of hair and frustration trying to simplify a problem or solve a problem. Knowing that A, or some number, times the reciprocal of itself is equal to 1. So A times 1 over A is equal to 1. So how do I get that 1 again? Well, you take that 3. If you multiply by the reciprocal of 3, which is 1 over 3, it's going to equal 1. Very important. So why? Because 3 is the same thing as 3 over 1. So when I do, multiplication here. So when I do multiplying by 1 over 3, in essence, we're going 3 times 1 is 3, and 1 times 3 is 3. 3 over 3 is 1. So that's what we're going to get, 1. Find the additive inverse of each expression. So what's the additive inverse of 13? So additive inverse is 13 plus something is going to give me the opposite. You know, we're talking about an inverse plus the opposite. So negative 13 is going to equal 0. And if I had negative 5/8, that looks complicated because it's a fraction, but it's not. I'm just going to add the additive inverse of negative 58, which is just 5/8, because negative 5/8 and 5/8 equal 0. What about 0.6? 0.6, what the additive inverse of that? Well, just add a negative. Negative 0.6 is equal to 0. So there's the additive inverse there. What about the multiplicative inverse? That's a cool sounding word, I think. If you want to say multiplication, but it's multiplicative inverse. So what can I multiply this 9 by to make it a multiplicative inverse. Well, we talked about the multiplying it by the reciprocal. Multiplying it by the reciprocal will give us 1 because 9 divided by 9 is 1. Because you remember, this is the same thing as having 9 over 1. What about negative 1 over 9? Well, if that's a negative 1 over 9, I'm going to multiply by the reciprocal of negative 9 over 1. So notice I did use that negative as well, right? I did this whole thing because negative times a negative gives me a positive, and in this case, a positive 1. And if you don't see it completely, if I did it step by step, it would be negative 1 times negative 9, which is a positive, let's say, do it over here, positive 9, and then 9 times 9 is 9. Well, 9 divided by 9 goes back to 1, so in case you didn't see it previously. All right, what about 0? 0 is really easy and can be kind of tricky if you're not careful. So let's look at it this way. Anything times 0 is 0, right? So that should be pretty straightforward. So these problems here, negative 8 times 0, that's 0. 512 times 0 is 0. 0 times this is 0. Anything times 0 is 0. I love multiplying by 0. It's the easiest thing in the world, right? What about dividing by 0? So dividing by 0 is the one I say gets interesting because 0 divided by a number is 0. 0 divided by a number is 0. So these are two different ways to look at it. And think of it this way. So if I have 4 daughters. If I have $0 and my 4 daughters are asking me for money, they say, could you give me some money? Well, I'm like, well, I have to divide it equally between everyone. Let's take my $0 and divide it into 4 of you guys. How much are each one of you guys going to get? Well, the real life answer becomes pretty simple, doesn't it? You're not going to get anything. Or let's be mathematically technical here and just say you're going to get $0, $0. You're not going to get anything. I have 0. So if I take nothing and try to divide it, you're going to end up with nothing. So 0 here divided by 5 is 0. 0 divided by 7/8 is all that. No matter what you put there, if I put 0 divided by x squared minus 2, as long as, okay, I'm kind of getting ahead of myself because the denominator can't equal 0. That gets us into a different problem, which we're about to get into now. So what if for any real number a divided by 0 and a divided by 0 are undefined? Undefined. So let's think about that. At first I said, what if I had $0 and divide into my 4 daughters? That'd be 0 because they're not going to get anything. But what if I have 4 daughters? I don't want to say daughters and I'm dividing them. But let's say I have $4 and I divided that by 0. Well, you can't divide by 0. You can divide by 1 and it'll still give you 4, but you can't divide by nothing. There's no such that's not dividing. So we're going to call that undefined. As you see here, undefined. So anything divided by 0 is undefined. It's important that you see this because it's going to save some scratching your head later because you're going to see problems looking like this. Let's say x minus 2. So they're going to say solve this or something or whatnot. But one of the caveats that they're going to say is when x is not equal to 2. Why? Because if x is equal to 2, this is going to make this thing undefined. And they're asking you about everywhere but where x is equal to 2. So sometimes you'll see this little thing on the side. You don't have to make a big deal about it. They're just trying to say we don't want this to be undefined because we can't work with that. So you'll see that here coming up. All right, so here we go. So, right, 7.5 divided by 0. Don't even waste your time writing that down. I could just look at that and say undefined, undefined, and undefined. Simple, easy, for sheezy, pleasy. Okay, I'm done. All right, so let's kind of practice here with some of the things we talked about as we close this up. I can see that I can have an additive inverse with 3x and minus 3x. And I could have used the associative property, the commutative property, and move that closer to each other to see that. Didn't have to. Probably usually wouldn't, but why not, since we just talked about that maybe a few lessons ago. To see that these two are simply going to go to 0, because this is additive inverse that goes to 0, and I'm left with 15. Here, I can use the multiplicative inverse. How? Well, because the multiplicative inverse says if I have a number times its inverse, it's going to equal to 1. Well, I don't see that situation here. Well, until I understand that 0.25 is the same thing as 1/4. Well, now that gives me 4 times 1/4. And there's a Q there. So now I can see that actually it's the multiplicative inverse. 4 times 1/4, that's just 1. So I'm left with just 1 Q. And we don't usually write the 1 in front, so just Q would be the answer there. That's sufficient. So that's how we can use those rules. And let me go back up to that problem, because that's the beauty of it, right? It won't take long to solve this, but if this is one part of a much longer problem, then that's more headache that you kind of have to deal with. But if you had known that, first of all, 0.25 is a 1/4, and then 1/4 times 4 is equal to 1, now this problem got extremely much more simple, because in your head you just work, you're like Q. You know, people will be like, what? How do you do that? Well, just some basic understandings that you have from watching this video. Of course, you're like, oh, that's a great video, you got to check it out. So let's do this one. 0 divided by whatever this is, where n is not equal to -5. Why? Because we don't want an undefined term there. So, but 0 divided by anything is equal to what? 0. 0. By the way, oftentimes in math, you'll see people put a cross through the 0. Why? Because you don't want to confuse the 0 with the letter O. So that's just a kind of side note. Same thing with the number 2. We differentiate that from the Z by putting a line through the Z, and we differentiate a 1 from a 7 by putting a line through it, so it's not confused with the 1. So there's some things in numbers that you want to kind of get used to seeing, or even writing yourself, so that no teacher or anyone looking at your work will be confused. If you ever had to give a VIN number for a car or some long number that's alphanumeric, you understand what I'm talking about, because you can say O, you mean O or 0. All right, so anyhow, this is divided by 0, and we know that anything divided by 0 is undefined. You can't divide something into 0 parts. That's just not possible. Just leave it alone. So you want to say, oh, it's going to be the same thing. Well, if it's the same thing, we'll divide it by 1, because they're just the one thing, but you're not going to divide it into 0. All right, 3/4 times 4/3. What property can we use here? Well, 3/4 times 4/3, that's the reciprocal. All they did was flip this one. I don't like to say flip, but I say it just to make sure you understand what I mean, because I'd rather say reciprocal, where we switch the numerator with the denominator. So 3/4 times 4/3 is going to equal 1. So I now know 1 times all of this, and that's just going to give me all of that, 6x plus 12. So that looks complicated to somebody who hadn't trained as you did, but looking at this, you'd be like, oh, that's just 1. Well, how do we know? I'm going to just make sure I make this point clear. 3 times 4 is 12, 4 times 3 is 12, 12 divided by 12 is 1. So I can see that that's going to be 1. And I just start to learn that when you multiply reciprocals, they're going to get 1. Multiplicative inverse. All right, bam, here's a review of all the properties we just covered, we've been talking about all in one place. So I'm not going to go over that again, but I did kind of want to give you a snapshot of what we just did. Did we accomplish our goal? We recognize the identity property of addition and multiplication. We use the inverse properties of addition and multiplication. We use the properties of 0, yep. And we simplified expressions using those properties. That's what we did at the end. So thank you for tuning in. Brandon Clayton here, the Algebra Guy, and I will see you next lesson.